So today we're going to start with the endocrine system, and the study points, according to the FSMTB, are understanding the effects of massage and bodywork on the endocrine system, understanding, identifying the location of the endocrine glands, and the basic functions of each gland, such as insulin in the pancreas and estrogen in the ovaries. So that's just basically what kind of hormone is produced by which gland. Understanding the effects of more commonly discussed hormones like adrenaline and melatonin, and then understanding the roles of the hypothalamus and the pituitary glands in controlling other glands. You will not have to know involved chemistry concepts like the concepts of thyroxine. So they're saying how the thyroid puts together the components of thyroxine to form thyroxine or thyroid hormone. You don't have to understand those things. So we're going to start with, let's see, let's put this slide last here. So let's start with the hypothalamus and the pituitary. And if you go to my YouTube channel, under the MBLEx folder, you can go down to hypothalamus and pituitary. So I'm not going to search for the video, but I have a newer one here, and this one has more than enough information. In fact, it has some things that you probably will not need. However, it does have this really nice handy drawing of the hypothalamus and the pituitary gland, and understanding the anatomy will definitely help you to understand how they control the rest of the endocrine system. So let me see if I can find you a really clear. Yeah, that was pretty good. Okay, so this is the brain, right? So this is what's called the cortex. The cortex is the outside of the brain. Importantly for us, the cortex is the conscious part of the brain, right? So it's the one that receives sensory information from touch, smell, sight, taste. It's the one that we're aware of, right? And then underneath the cortex is the gray matter, and within the gray matter there is an emotional center, and then there's a control center. The control center is in the thalamus and then in the hypothalamus. So the thalamus is this area here, and then below the thalamus is the hypothalamus. That's why it's called the hypothalamus, just because of its geography, basically. Well, because of its anatomy. The hypothalamus and the pituitary gland, they control the actions of all the other hormones. The hypothalamus is known as the master controller, etc. Those words should be like pretty self-explanatory, right? But its job more specifically is to receive information and to tell the pituitary gland what orders to give to the other glands. So if you look at the hypothalamus, it's shaped kind of like in the anterior part. This is the anterior and this is the posterior. In the anterior part, there's a little bit of a corner, and then there's the hypothalamus, there's the pituitary gland, which hangs off of it. And I just want to acknowledge that some of these drawings look like penis and balls or boobs, and you know what, older anatomists, they also recognize that. Like, I forget what this structure is called here, but they actually called them mammaries. I think it's called the mammillary body or something like that. Anyway, anatomists have just as much as they were teenagers once too, and they have a sense of humor. So If we take this area here, this red area that has a corner, the hypothalamus, and we blow it up, what we get is a figure that looks like this. Where's my hypothalamus? There's. So here's the corner right here that we were seeing earlier. Looks like there's a little bit of a lag on the video, so I'm just waiting for that to catch up. Oh, it's kind of glitching. All right, for some reason when I have full screen, it glitches, like the screen flashes back and forth on Zoom between the current image and the previous image, so it flashes or toggles quickly. If it does that, please unmute it and let me know that it's doing that, okay? Because it looks like I really cannot use the full screen feature, and sometimes I forget. So here's the corner right here, and then the pituitary gland is hanging down off of the hypothalamus. So inside the hypothalamus are all these nuclei, and this is a term that you may or may not have to know for the MBLEx. The concept I believe that they want you to know is that nuclei is the correct term in the central nervous system, so the brain and the spinal cord, and then ganglia is the correct term in the peripheral nervous system, so outside the brain and the spinal cord. What nuclei in the central nervous system and ganglia in the peripheral nervous system, what nuclei are areas where the nerves interface with each other, and they make these dense areas. Oftentimes, the nuclei are made up of nerve cell bodies, not just axons. Remember that neurons have they have a body. You can see it right there. Yeah, they have a body on them that's like a head, and then they have a long part that's an axon, right? And it's the axon that conducts action potentials or conducts nerve impulses. The body, however, its job is to act as the main part of the cell. So it's got the nucleus and all the other organelles in there, and it also receives information from other neurons, from other nerve cells. The axon terminals down here, they also do that. So you have the body, and it's not shown here, but there's lots of little tree-like extensions that grow out of the body, and these extensions they reach outward, and they also serve to increase surface area or the amount of contact they can have with other structures. So when nerves or neurons meet with each other in the hypothalamus, it's to their advantage to have their nerve bodies and their dendrites or their extensions facing each other, contacting each other, so they can share information much more efficiently, right? So you end up with these areas of kind of distinct thickening where the nerve bodies or the neuronal bodies start to connect. And in the central nervous system, they call those nuclei. So each nucleus in the hypothalamus has a specific role. For example, there are nuclei which receive ocular information, and there are nuclei which receive information about temperature or information about the concentration of water in the blood. I'm sorry, there we go. And for the most part, these nuclei, they receive what are called afferent, what are called efferent with the letter E, efferent sensory information, efferent letter E, sensory information. And then they send afferent motor impulses down into the pituitary, sometimes into and sometimes towards, depending on whether it's the posterior or the anterior pituitary. So if they ask you what's the role of the hypothalamus, you can say that the hypothalamus is like the the monitoring center or the command center. It monitors it monitors all the levels in the body. It receives all the sensory information in the body, and it's the starting point of maintaining homeostasis. It receives data and then it decides what to do with that data or what to do with that information. So if for example, if your blood volume is a little bit low, your blood pressure is a little bit low because you're a little dehydrated, the hypothalamus will send a message to the posterior pituitary gland and say, release this hormone called antidiuretic hormone. And the antidiuretic hormone then flows in the bloodstream from the posterior pituitary through the bloodstream, and then it binds to the kidneys. And when it binds to the kidneys, it causes them to retain water. So the retention of water in the body allows the pressure in the blood vessels to start to rise because there's more water in the blood vessels. So there's more blood in the blood vessels, and then the amount of pressure in the blood vessels increases, right? So that's in a nutshell how the hypothalamus works. And its job for the most part is to receive information and then to tell the pituitary gland what to do. I apologize on the video. If you watch the video, this is mislabeled. It has an arrow coming in, meaning sensory information is being received into the central nervous system, into the hypothalamus, and it's marked as afferent. That's not correct. It's efferent with a letter E. I should redo that. It's efferent with a letter E, and you should remember information that the hypothalamus is receiving. Wait a minute. No, I'm sorry. This is correct. Afferent. You should remember information that the hypothalamus is receiving as arriving at the central nervous system. So afferent, letter A, arrives. So afferent is sensory. It arrives at the central nervous system. Afferent, letter A, arrives at the central nervous system. Efferent, letter E, exits out of the central nervous system. So you guys, I teach this stuff a couple times a month. I have to bring things up. I have to recall things like afferent and efferent, and even I will never recall things like afferent and efferent unless I go through the trouble of saying arrive and exit. How about close the doors? Okay. So once the impulses are received by the hypothalamus, an efferent impulse goes down into the pituitary gland. And now we're going to expand the pituitary gland, which looks like this, right? So here's the pituitary, right? Here's the corner we were mentioning earlier, which is the hypothalamus, right? And these are the nuclei, or crude drawing of the nuclei, right? Areas where neuronal cell bodies are meeting and interacting, sharing information. So let's say that that the hypothalamus receives information about blood pressure being low, blood volume being low. That information would come in to the hypothalamus through afferent, letter A, as in arriving at the central nervous system, coming through afferent sensory nerves. It would arrive at the nuclei in the hypothalamus that's responsible. Hold on a second. Hey, Xander, I really can't compete with that. So I just need you to go stay in your room, okay? Because I can't compete with you moving stuff around and dropping things right now. Afferent, letter A, arrives in the central nervous system, and then the nuclei would send the impulse through efferent, letter E, exiting, efferent, letter E, exiting the central nervous system, impulses into, in this case, the posterior pituitary, which stores and releases ADH and vasopressin, ADH or vasopressin, ADH, antidiuretic hormone, vasopressin, just another name for antidiuretic hormone. I have seen practice questions that ask, whether ADH or, prolactin or this hormone or that hormone is stored in the posterior compared to the anterior pituitary. I would be prepared to answer those if I were you. If nothing else, it's a little bit more clarity on the orientation, right? A little bit more clarity on the anatomy. So I would consider that like a secondary layer of information, something that you could practice after you get down the fact that the hypothalamus receives information, monitors the information from the body, monitors all the systems of the body, however you want to put that, monitors the body, and then tells the pituitary glands what hormones to release, and then those hormones then tell other glands what hormones to release. So, and then you can memorize the hormones if you like. Okay, so in the posterior, it's antidiuretic hormone, also called ADH, and vasopressin. Those are the same hormone. Also is oxytocin. If I'm not mistaken, oxytocin is actually a type of endorphin. I'll look that up in a moment, but those are the only two in the posterior pituitary gland. In the anterior pituitary are all these other 7 hormones, and you can remember them through the acronym FLAT PEG. So FLAT is follicle stimulating hormone, and then luteinizing hormone. Follicle stimulating hormone and luteinizing hormone are those that are responsible for the production and the release of ova in the ovaries, and also the production and the production of testosterone and sperm in the male. And then ACTH, adrenocorticotropic hormone. So we're going to get into the word breakdown a little bit. So adrenocorticotropic and word breakdown. So adreno refers to adrenals. Adreno refers to adrenals, and cortico refers to cortex. The cortex is the outside. The cortex is the outside of any structure. The brain has a cortex. Also, the adrenal glands also have a cortex. The kidneys have a cortex. There's a cortex on the outside, and then inside there's a medulla. Maybe I should show it like this. There's a cortex on the outside, and inside there's a medulla. So adreno is the adrenals. Specifically, it holds to the cortex or the outside of the adrenals. Tropic refers to the cells, specifically cells that manufacture hormones. And then the last word is hormone, which of course means hormone. So adrenocorticotropic hormone, right? So follicle stimulating hormone, luteinizing hormone, adrenocorticotropic hormone, and then thyroid stimulating hormone. So hopefully that's intuitive for you, that the thyroid stimulating hormone is the one that is, take that away from, is the one that stimulates the release of thyroid hormone. And then there's prolactin. Just put the food on the floor and take the empty bowl away so he doesn't rattle around. Guys, I'm sorry, it's like, it's a little bit much to manage everybody in the household and manage my class. It would be nice if I could split these jobs up so that they don't interfere with each other and interfere with your experience. I'm sorry. I taught them better than that for sure. Follicle stimulating hormone, luteinizing hormone go to the gonads of the female, the ovaries, and the gonads of the male, the testes. Adrenocorticotropic hormone goes to the cortex of the adrenals. ACTH, adrenocorticotropic hormone, releases cortisol. Cortisol is a stress hormone. It elevates blood pressure, increases our awareness, depresses our immune function, causes swelling in the body, thinning of skin. It's weight gain. It's bad news. Cortisol. We need some of it in regular healthy homeostatic amounts, but usually the stress of a modern life causes cortisol to be elevated rather than homeostatic. Then there's thyroid stimulating hormone, which stimulates the thyroid. Prolactin, which causes lactation or breast milk production. Endorphins are, let me get you the specific endorphins, because there's, I think, 2 or 3 of them, there's 2 or 3 which I want you to know, or I want you to be familiar with. So one is, so first of all, endorphins, they decrease pain and they increase sensations of pleasure. Okay, dopamine. So dopamine and I think serotonin. Oh yeah, they often, even when they're breaking things down, they often just summarize them as endorphins. Okay. Most common endorphins. All right, so it'd be enough for you to yeah, here we go. Dopamine, serotonin, and oxytocin also is a type of endorphin. So it can be a little confusing looking at the anterior and the posterior pituitary gland, thinking, okay, flat peg, PEG, letter E, endorphins in the anterior, so that must be dopamine and maybe serotonin, and oh, I think oxytocin is an endorphin, so that must be in the front. No, unfortunately, oxytocin is produced in the back. So no mnemonic device is perfect. Just try to remember that of the endorphins produced, oxytocin is one of the most important, and it's produced in the back. Okay. Do you guys have any questions? Oh, by the way, the pituitary gland is called the master gland. The master gland. They probably will use those terminologies on the MBLEx, the master gland. So the pituitary controls the actions of all the other glands in the body, and the hypothalamus is like the monitoring center. It monitors the body and tells the pituitary what commands to give to the other glands. So if you were to draw like an axis, like a control, like an order of, what is that called? If you were to draw in order of rank, like the general at the top, and then the commanders, and then the soldiers, at the very top, monitoring everything would be in the general's position, the hypothalamus. And then the commanders, the master gland is the pituitary, and then under that would be all the soldiers that do all the work, or all the workers that do all the work, or all the endocrine glands that do all the work. Do you guys have any questions about the hypothalamus or the pituitary, or any of the hormones that are produced, or how the hypothalamus and the pituitary interact with the rest of the glands in the body? Okay. No. Yes. Okay. All right. So you guys let me know if you do. So that's the roles of the hypothalamus and the pituitary in controlling other glands. So we have to move on now. We're going to move on now to like the basic functions of each gland, the locations of the endocrine glands, and we're in the process discussing the more commonly discussed hormones such as adrenaline, melatonin, and we're going to end with the effects of massage and bodywork on the endocrine system. So if we look at the endocrine system, actually, let me see if I can just find a larger. Oh, I can just do this actually. Yeah. If we look at the endocrine system, we see that the anatomy follows the chain of command, right? So you have the hypothalamus at the top, which monitors everything. And then under the hypothalamus, you have the pituitary gland, right? Hypothalamus at the top monitoring, pituitary gland as the master controller giving the commands. And then descending from that, you see all the other endocrine glands. So you have the thyroid, which produces thyroid hormone. You have the thyroid and the thymus, pancreas, the adrenals, which renal means kidney, ad means close to, so you have on top of the kidney, so adrenal. And then you have the ovaries in the female, the testicles in the male, and the placenta is considered to be an endocrine gland during pregnancy. So the specific hormones produced by the glands are thyroid stimulating hormone. Thyroid hormone or thyroxine. So thyroid hormone, its role is to stimulate metabolism in the body. So when people have adequate amounts of thyroid hormone, their cells are multiplying, their tissues are repairing. If they break a bone or have a cut or they get sick, their body heals in a timely fashion, right? They don't gain too much weight, they don't lose too much weight, and their temperature is normal. When there's not enough thyroid hormone, the body's metabolism will be depressed. So the body will be cooler rather than a normal temperature. Its various systems will run at a lower percentage. So people will be tired, their cognitive ability will not be as high. Any kind of injuries or infections will take longer to heal. You also see that the basic regeneration of the tissues in the body, like the skin, are affected. Oftentimes people who have hypothyroidism, their skin is a little bit thinner, except for the skin on the back of the neck, which tends to thicken. That's called Cushing syndrome. You don't need to know that, but it's just kind of interesting, gives you some context. They also tend to gain a lot of weight because the metabolism is low, so the activity in the body is low. Fat and sugar are not being broken down and utilized for fuel as much as in someone who has regular homeostatic levels of thyroid hormone. Let's see what else. Fatigue. They'll also be fatigued. If someone has elevated thyroid hormone, that's going to look like a higher body temperature because of higher metabolism, higher body temperature. You would think that they would have some kind of super revved up immune system, and to an extent they do. They can be more prone to allergic reactions or what looks like an autoimmune response. Remember, allergies and autoimmune responses, those are the immune system attacking its own tissues or overreacting to things. So two people, when there's an excess of pollen being produced in the spring, like what I have right now, two people, one of them has stuffy nose and irritated eyes. That's a histamine response. That is the immune system reacting very strongly to the presence of pollen. And another person might not have any of that. That person's immune system is not overreacting to the stimulation of pollen. It's just dealing with it to the degree that is perfect for the system. Also with high amounts of thyroid hormone or thyroxine, you also will see excessive weight gain, redness of the skin. You can see more rapid heartbeat, more frequent urination, sometimes constipation. Okay, moving on, we have the thymus gland. The thymus, I don't know very well. Let's see. Oh yeah. So the thymus mainly it functions to produce immune or immune mitigating cells. So it produces lymph cells and what else? Main functions of the thymus glands. Yeah, produces immune mitigating cells, functions in the defense as a defense mechanism, providing surveillance, so that's collecting information, and protection against pathogens, tumors, etc. Let's see what cells. What hold on. Thymus produce. Yeah, thymosin. They're not going to ask you that. But if they did, you know, you would just out of a multiple choice question, pick the one that looks like the name thymus. But they're not going to ask you that. I don't think. Okay, pancreas. So the pancreas has a lot to do with digestion. So it does produce enzymes that through a tube travel into the top part of small intestine, and they help to break down like carbohydrates and proteins. But the pancreas as an endocrine gland, the pancreas controls the level of blood sugar. So there are two hormones that the pancreas produces. The main one is insulin, or the main one that most tests will want you to know is insulin. And that's because insulin is responsible for taking sugar out of the blood, lowering the blood sugar down to homeostatic levels, and then storing it in the muscles and the liver for the most part. The other hormone produced by the pancreas is glucagon, and glucagon, its role is to raise the blood sugar. So insulin pulls sugar out of the blood and stores it in the form of glycogen. Glucose in the blood, glycogen in the stored form. It stores glycogen in the liver and the muscles. Glucagon releases glycogen from the muscles and the liver and converts it to glucose. So glucose in the blood and glycogen in the liver and the muscles, and those are mediated by insulin, which lowers blood sugar, and glucagon, which raises blood sugar. So unmute yourselves for a second, and please call out. So if you have gone, you know, several hours without enough food, is your blood sugar going to be higher or lower?
Lower.
Low.
Yes, lower. That's right. Lower. And let's say that you have to do some kind of work. You have to walk home, or you have to teach a class, or you want to go work out in a fasted state or whatever. But you have low blood sugar. You can see how you would need to find a source of sugar. Your body would need to, it's called mobilize a source of sugar, right? So what does it need to release? Does it to mobilize a source of sugar? Does it need to release insulin or glucagon?
Insulin.
Insulin.
Okay, so insulin lowers blood sugar after we eat, and glucagon, yes, glucagon raises blood sugar when we need more sugar. So glucagon breaks down stored glycogen and releases it into the blood as glucose. Did you guys think that it would be insulin because insulin takes sugar and like gives it to the muscles so the muscles can run? Is that what you thought?
Yeah, that's what I thought. Yeah.
Okay. I am glad we clarified. So it's just being stored in the muscles. It's using the muscles as like a storage site, right? It's using the muscles and the liver as like a storage site. Oddly enough, first of all, like glycogen, the stored form of sugar in the muscles and the liver, glycogen can't be used directly for energy. It has to be converted into glucose first, and then glucose is used for energy to run your muscles and your brain and everything else. So let's do a couple more things like that, right? So again, you have fasted for a few hours, you're about to do some work, and you need to mobilize glucose. So that would be glucagon releasing glycogen into the blood as glucose, or glucagon raising the blood sugar. Glucagon raising the blood sugar. Okay, now you sit down with your family and you eat, and then your blood sugar goes up. Maybe you even have, carbohydrates or sugar or something like that, and the blood sugar goes way up. And excessive amounts of sugar can be toxic. And this is also an opportunity for your body to take a bunch of sugar and store it for later, because you are going to have to fast at some point, whether it's overnight sleeping or whether it's because you miss a meal or whatever. So what hormone would the pancreas release in order to take some of the blood sugar out of the blood? Insulin or glucagon?
Insulin.
To take sugar out of the blood, to lower blood sugar, to store sugar. Insulin. That's right. Insulin. Yes, insulin. Okay, you're about to go work out. You're on your way to the gym. You're about to go work out. Your body knows this. It wants to mobilize glucose. It wants to raise the blood sugar level so your muscles have more energy. What hormone is your body releasing? Insulin or glucagon to raise the blood sugar?
Glucagon.
Glucagon, that's right. And then after your workout, you have a shake, maybe you have some Twinkies or Ho-Hos or whatever athletes have after they eat, and your blood sugar starts to skyrocket. And your body wants to control that by lowering the blood sugar. What hormone is that?
Insulin.
Insulin, that's correct. That's correct. So food does what to the blood sugar? Raises or lowers?
Raises.
And yes, and when the blood sugar rises, what hormone is released in response to that?
Glucagon.
Glucagon.
When blood sugar rises, the body wants it to come back down to homeostasis. So what hormone does it use to lower the blood sugar back down to homeostasis?
It's
Insulin.
glucagon. It's the other one.
Insulin.
It's insulin. It's insulin. I hear some of you wonderfully diligent students saying both insulin and glucagon.
Yeah. Yes.
Okay, guys, let's drill this just a couple more times. Okay. So insulin lowers the blood sugar. That means it lowers it down. Lowers it down to normal homeostatic level. Homeostatic level is like where you can do a certain amount of work, not heavy thinking, but you can do a normal amount of work, right? That's what insulin does. It lowers it down to a homeostatic level. Glucagon raises insulin, hopefully up to a homeostatic level. When you eat, your blood sugar goes way above homeostasis, and insulin has to bring it back down. When you fast, your blood sugar goes down below homeostatic level, down below balance level, and glucagon has to bring it back up. So after a meal, your body has to do what? Lower the blood sugar back down to homeostatic level, or raise the blood sugar up to homeostatic level right after you've eaten. What does your body have to do?
Lower.
It has to lower it. That's right. That's right. And if you're fasting, fasting is relative. For some people, fasting is 5 hours without food. For some people, it's 12 hours without food. So if you're fasting, what does your body need to do? Increase the blood sugar or lower the blood sugar to homeostatic level?
Increase.
Increase the blood sugar. That's right. And which hormone is it that releases glucagon? Shucks. Which hormone is it that releases glycogen in the form of glucose to raise the blood glucose level? Which hormone does that? Insulin or glucagon?
Glucagon.
And which hormone is it which pulls glucose out of the blood, lowering blood glucose levels? Which hormone does that?
Insulin.
Insulin. And what's the stored form of sugar called? Glucose or glycogen?
Glucose.
The stored form in the muscles and the liver is called glycogen.
Glycogen.
And the usable circulating form of sugar is called what? Glucose or glycogen? The sugar in the blood that we can use, that's in the usable form.
Glucose.
Glucose, that's right. Stored form is called
Glycogen. Glycogen.
glycogen.
Okay,
Glycogen. And it gets there through the hormone glucagon or insulin.
Glucagon.
Okay, I should rephrase the question. We get glycogen by pulling glucose out of the blood and storing it as glycogen, and that hormone is
Insulin.
insulin. That's right. And then that's right. And then we raise the blood sugar through what hormone?
The glucagon.
Glucagon. That's right. That's right. Very good. Very good. And those are all produced in the adrenal glands, right? No, I'm just kidding. I'm joking. Those are all produced in the pancreas. Yes.
Pancreas. Okay.
Pancreas. Okay. You can go ahead and mute yourselves, please. So moving right along, we've covered 3 of these glands and we have 1, 2, 3 more to go. So now we have the adrenal gland. So again, renal means kidney, ad means close to, so it's on top of the kidney, right? And the adrenal or adrenal gland, it produces 2 hormones. I can't really say like which one is more important, so I'll discuss them both, right? So the cortex or the outside of the adrenal which is this part here, the cortex, right? The cortex that produces cortisol. Cortisol is a stress hormone, and cortisol is responsible for a whole lot of nasty effects in the body, and also some good or some useful effects. So one thing that cortisol does that's useful is that it helps to increase your blood sugar. It helps to increase your blood glucose. So if you are stressed, if you need to keep going, if you are fasting and you don't have time to eat, your body will release cortisol in order to release more glucose than usual. Now, over time, if you fast over, after the first day of fasting, you may produce a lot of cortisol. The second day, not so much, but the body will start to get it that it's running fine and it doesn't need as much cortisol. And the body likes to reduce whatever it doesn't absolutely have to produce so that it can conserve energy, so it can conserve resources, right? So some of the positive things that cortisol can do in the short term are to increase blood glucose, to make you more alert, more aware. People with people who have traumatic experiences, they will feel very, very alert and very aware for several hours or maybe even a few days. But long term, what cortisol does is it has a very, very detrimental effect on our bodies. It causes us to gain weight, especially around the midsection, because we have all this circulating glucose, and the glucose starts to interact with the building of lipid, or the building of fat cells, as well as cholesterol and other lipids. Lipids are a type of fat, another word for fat, right? So the balance of cholesterol and fats in our bodies gets off. Cortisol suppresses the immune system because, if you're stressed or if you're under threat, stress is a kind of perceived threat, right? Whether it's there or not, is another story. But when your body or your brain thinks that you're under threat, it doesn't have time to deal with like cold or a flu or a cut or whatever. It's got to mobilize glucose and use all the other resources, the sugars and the fats and the brain power, in order to get away from the tiger that's chasing you or whatever, right? So our immune system doesn't respond to infections the way that we need it to, which can be quite dangerous, especially in people who are already immune compromised. And it also tends to make us over time very, very, very angry, very grumpy, right? That's because we're not getting the rest that we need. We don't sleep as deeply when our cortisol is elevated. Sometimes we don't even, sometimes people get things like insomnia, or they sleep shorter periods than they need to. And also our brain is working all the time. Our brain is hyper aroused and it's staying in kind of a sympathetic fight or flight state or fight or flight tone. Even if it's just a little bit, we're not dropping down into that area where our brain can really shut down, our heart rate can really fall back down to homeostatic levels, and our body can shut down and regenerate. So cortisol is very, very powerful and very, very deleterious over the long term. In the short term, it does some good things, but over the long term, cortisol is very dangerous. And then in the adrenal medulla, the medulla I believe it's the medulla that releases epinephrine and norepinephrine. So epinephrine used to be called adrenaline, right? And norepinephrine is a hormone that looks like epinephrine. So epinephrine opens and activates things. If you have a histamine response, epinephrine can a histamine response, and you get clogged in your sinuses. Epinephrine can open that up. If there's a strong enough immune response and someone's throat or bronchi are starting to constrict and they can't breathe, epinephrine is often given in order to dilate the bronchi and open the throat. It's also used to help the heart to start beating if it has stopped, or to regulate the heart rhythm in an emergency. A shot of adrenaline. Okay. I don't think that they're going to ask you about, which hormone is produced where, the cortex or the medulla. I think that's a little bit too specific. I would call that like the third layer of information, maybe even the fourth layer of information or knowledge for the endocrine system. Okay, and I think it's almost time to go on to some, oh, no, we have to cover the reproductive system. So in the reproductive system, you have the ovaries, the placenta, and then you have the testicles. So the placenta really only produces hormones during pregnancy. I think it produces a small amount of progesterone to help the embryo to implant and to stay implanted. And I think it may be the one that produces relaxin, which softens the tendons and the ligaments in the body so that the pelvis can open and more easily pass the infant through the birth canal. So the ovaries produce estrogen and the testicles produce testosterone. The ovaries produce eggs and the testicles produce sperm. And that's like, I think we all pretty much know that. Do you guys have any questions about the organs of the endocrine system? Is anything unclear? The most complicated ones, detailed ones, are the pancreas and the adrenal glands, right? And for the pancreas, you really just have to keep in mind blood sugar being high and lowered. Being high releases insulin, and then insulin lowers blood sugar, and then blood sugar being low triggers the release of glucagon, and glucagon raises blood sugar. So if blood sugar starts to fall, or if cortisol starts to rise, or if the amount of circulating testosterone starts to fall, which part of the endocrine system, or which part of the nervous system actually, which area of the brain is it that receives that information?
The hypothalamus.
The hypothalamus, that's right. And then the hypothalamus sends its commands down to which gland?
Pituitary gland.
The pituitary gland. And what's the nickname? Okay, someone else now. What's the nickname for the pituitary gland? Somebody just left. What's the nickname for the pituitary gland? Khalees.
Is this something like growth or like important?
It's the control gland,
Control. Okay.
or the master controller. I don't like words like master and control. Like, we all know how those found their way into anatomy and physiology, but that's what they're going to ask you. The master controller gland, or the controller gland. Yeah. And that's because it tells the other glands in the body what to do. Okay, so Stephanie.
Yes.
When the hypothalamus receives information, when information arrives into the brain, is it arriving through afferent letter A or efferent letter E neurons?
Afferent letter A.
Yes, thank you. Thank you. Okay, one more term that I want you guys to know, and that is effector tissues. They may or may not ask you this. So an effector tissue is any tissue that receives hormones, spelled, I'm just writing it here to spell it for you. It's any tissue in the body that receives hormones and responds to them. So that can be muscles or bones receiving like growth hormone that tells them to grow, right? It can be an effector tissue can be the adrenal glands receiving adrenocorticotropic hormone. It can be the heart or the lungs receiving epinephrine. It can be the ovaries receiving luteinizing hormone or follicle stimulating hormone. You guys get the picture of what is an effector tissue? It's all the tissues in the body that are subject to hormonal influence. Okay, so I think it's time to move on now to the questions. Yeah, so I'm gonna close this down and we'll go over some of these questions. So for this, we need to we're gonna do a few questions and then take a break. Which system is in charge of secreting the hormones that regulate temperature, metabolism, and blood pressure? Is that the reproductive system, the endocrine system, the urinary system, or the integumentary system?
B.
Endocrine system.
B.
Endocrine system, yes. Yes. If anyone is really confused about any of the answers, please let me know. The endocrine system is in charge of what functions for the body: maintaining homeostasis, controlling growth and development, reproduction and metabolism, or ensuring continuity of the species, supplying oxygen to the blood while removing carbon dioxide, returning leaked plasma to the blood vessels, and providing a site for immune surveillance.
Maintain homeostasis,
Yes.
control growth and development, reproduction, and metabolism. It
That's
has
right.
that
Yes.
correct answer down on the bottom.
Yes, I know that. And it's highlighted here at the top because I didn't
Okay.
take a photograph of the unmarked question. Yes. But I still got to go through the motions with you guys. So
Okay.
question for you: returning leaked plasma to the blood vessels and providing a site for immune surveillance. Which system does that? Is that endocrine, lymphatic, circulatory, or respiratory? Returning leaked plasma to the
Circulatory.
blood.
Circulatory.
Lymphatic.
Yeah.
Lymphatic, yeah. Supplying oxygen to the blood while removing carbon dioxide, is that lymphatic, reproductive, or circulatory?
Circulatory.
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 I'm sorry, I didn't give you the right choices. Lymphatic, reproductive, or respiratory.
The respiratory.
Respiratory, and then ensuring continuity of the species, is that reproductive, respiratory, or endocrine?
Reproducing.
Reproductive, that's right,
Yeah,
reproductive. Yes. In homeostatic relationships, what does the integumentary system do for the skeletal system? What is the integumentary system, by the way? Is that the skin, the muscle, or the bones?
The skin.
And
Yes, it's does the integumentary system also includes the hair and the nails? So what does the skin or the integumentary system do for the skeletal system?
It provides.
Does
Oh, sorry.
go ahead.
I was gonna say B. It provides support for the skeletal system.
Well,
uh,
just relatively speaking, do you think that the skeletal system is supported more by the muscles or by the skin?
The muscles.
Yes. And does the skin produce vitamin D?
Mm,
Yes.
okay.
Yes. And how about vitamin C? Does the skin produce vitamin C?
mm,
No, we have to
No.
ingest vitamin C.
Okay.
And then how about salts? Does the integumentary system contain salts that are needed for bone marrow?
Yes.
No, that's a weird one. I don't know. It doesn't contain salts
Okay.
needed for bone marrow. No. I think we have to ingest that. So it synthesizes vitamin D for the bones. It's the muscular system that provides support for the skeletal system. Vitamin C and then salts, they both have to be acquired through the diet.
Okay.
All right. What body system activates vitamin D for calcium absorption in digestion? Is it the endocrine, cardiovascular, lymphatic, or nervous system? It's the endocrine system. Yes, it activates vitamin D, for calcium absorption in digestion. You guys understand that vitamin D has to be in the gut next to calcium in order to take calcium into the blood, from the gut into the blood. There's kind of like there's something about calcium. It's either the shape or the charge that doesn't allow it to be absorbed from the small intestine into the blood. Vitamin D has to be there to carry calcium across the small intestine wall into the blood. So it's the endocrine system that produces produces a hormone that activates vitamin D. It's called catecholamine. You're not going to need to know that, catecholamine. Which gland is in charge of the growth and development of the body? Is that the thyroid, the adrenal, the pituitary, or the reproductive, the growth and development of the body? It's listed right there. It's the pituitary gland. But you could see how this would be confusing, right? Because the thyroid gland does what? When you hear thyroid, I want you to think metabolism.
Yeah.
Yeah, it increases metabolism, and metabolism is building up and breaking down. It's breaking down and cleaning things out, and also building up, replacing, and healing, right? So you can see how the thyroid gland I can see how that might appear to you to be one of the answers. And then the reproductive glands, they produce the sex hormones, estrogen and testosterone. So both of those play a role in building things like lean muscle and bone density. So that also might be a little confusing. So how do we differentiate in this question? This is like a test taking strategy. How do we differentiate in among three possible answers, all of which are correct? How do we differentiate between those here? How do you know it's the pituitary and not the thyroid, not the reproductive glands?
The pituitary gives out the command to all the glands.
That's right. That's correct, because the pituitary is the controller or the master controller. Also, Also, in order for the thyroid or the reproductive glands to do its work, the pituitary has to do its job first. So you can think about it like that. Chain of command. Okay, the body's cells consume what for fuel? Lactose, glucose, sucrose, or fructose?
Glucose.
Glucose, that's right. Glucose. Glucose is the fuel consumed by our cells. The endocrine system produces a hormone called erythropoietin that stimulates, let's see, Emmy. Emmy,
Sorry, I'm still thinking.
that's okay. How are you doing?
Good.
Do you remember if erythro means red or white?
I'm pretty sure it means red.
Yes, and which one means white? Do you remember the word for white? Leuco. Leuco. So erythrocytes are red blood cells. What do you think poietin does? Without looking at the answers, what do you think erythropoietin does? Erythro refers to red, like red blood cells. What do you think poietin does? Produces or breaks down red blood cells?
Produces.
Yes. Does that make sense to you? I hope that makes sense to you. Produces red blood cells. Reproductive.
Yeah,
The other
yeah.
answers.
A.
Cool.
Sorry, you froze for a second. I couldn't hear you.
Sorry about that. The other answer, possible answers are reproductive system, production of atrial natriuretic peptide, or all of the above. So it's red blood cell production. Erythropoietin, also known as heme like blood, hematopoietin or hemopoietin, is produced by the kidneys and is the hormone that stimulates red blood cell production. So erythropoietin is a little unusual in that it's produced by the kidneys. I do not think that they're going to ask you to differentiate between the sites of production of erythropoietin among a bunch of multiple choice questions. I don't think that they're going to ask you that. The peptide oxytocin hormone is released by what major endocrine gland? So where is oxytocin released? The adrenal medulla, the posterior pituitary, adrenal cortex, or anterior pituitary?
Posterior pituitary gland.
Posterior pituitary. Yeah. Can you guys name one hormone produced in the anterior pituitary? Remember the acronym FLAT-PEG. FLAT-PEG. Everybody name one.
This.
So I guess I will assign them.
TSH.
TSH is one, right? Thyroid stimulating hormone.
Oh,
Uh,
FSH.
TSH, thyroid stimulating. SH means stimulating hormone, and there's a few stimulating hormones among that FLAT-PEG hormones. So there's thyroid stimulating hormone, and then letter F would be follicle stimulating hormone. Khalees, do you remember letter L?
Yes, LH.
LH, yeah, and it stands for what? It's a very tricky word, actually. Luteinizing hormone. You can remember that by the luteal phase, the follicular versus compared to the follicular, and the luteal phase are the reproductive phases of the reproductive cycle. So that's the production and then the release. The follicle stimulating hormone produces or matures the egg, and then luteinizing hormone releases the egg. Right. Let's see. Emmy. Everybody unmute yourselves. We have 3 more people in the class, and only 2 are unmuted. Okay, so you guys, what about A? Do you guys remember A? It has to do with the adrenals. It has to do with the cortex of the adrenal. What's that one called? So the adrenals and the cortex. Put those two together.
Adrenal cortex. Adrenals, corticotropic.
Somebody said adrenal cortex, and that's very close. Yeah, if you just say adrenal cortex, you can pick out the actual name from the multiple choice, which would be adrenocortico. Adrenocortico. Does that sound like totally unfamiliar to you guys? Adrenocortico? I hope not. Okay, how about T? I think we already said this one, thyroid stimulating hormone, and then PEG, flat PEG, PEG. P is the hormone that causes lactation. Which hormone is that? It has the word lactin in it.
It produces milk.
Yes,
Prolactin.
Breast milk.
prolactin, that's right. And pro means what, Khalees?
Pro means
Pro is like pre.
so
Like-
like before.
Yeah, before it's the hormone that comes before milk, or the hormone that arrives ahead of milk. And then PEG, so E is a group of hormones like dopamine and serotonin. What's that group called? They make you feel good and reduce pain.
Dopamine.
Dopamine is a type of this category that starts
Oh,
with letter E.
endorphins.
Endorphins, yes. Yes. Stephanie, where are you at?
Sorry, I have a lot of noise in the background.
Okay,
That's
that's all right. That's
Uh,
okay. That's okay. There's one more left, and it's the one that I actually didn't go over with you guys earlier. I didn't mention. And guess who gets it? I'm joking. It's letter G is growth hormone. You can mute Stephanie. I'm sorry. Letter G is growth hormone. Now, growth hormone stimulates the growth of other cells in the body, and it also stimulates more production of testosterone and some production of estrogen, I believe. But growth hormone is the precursor to testosterone and the building up of the body. So PEG, prolactin, and endorphins, and growth hormone. Growth hormone is also known as human growth hormone. So you see it referred to as HGH or as GH. You guys feel completely overwhelmed by this?
Not really, no.
Okay, great. I mean, when I learned it, even just this level, when I learned it, it was impossible. Now, if you guys start to feel like really confused about it, you just let me know. We'll go over it again at a faster pace. Let's do one more and then take a break. What system is in charge of metabolism and blood pressure? Reproductive, integumentary, endocrine, or urinary? That's the endocrine system. Epinephrine is released by the endocrine system to help which body system? Remember, epinephrine dilates the lungs and the bronchi and also regulates the heartbeat or increases the heartbeat. Does epinephrine help the nervous system, the respiratory system, the digestive, or the lymphatic? You have to pick the most correct answer. It'd be the respiratory system. Okay, that's enough for now. So you guys take a break. It's 12:11, so come back at 12:21 Eastern time. Come back at 12:21 Eastern time. So we're going to finish up with the endocrine system. Please let me know if you cannot hear me or if anything is off. Okay. The question is a hormone that is produced by the pancreas and helps to metabolize glucose. So I want to clarify, what does it mean to metabolize glucose? What does that mean? Does that mean to pull it out of the blood and store it, or does that mean to put it into the blood from its stored form? What does metabolize glucose mean?
It's to put it into.
Put it into the blood?
Yeah.
Okay, actually metabolize, it means the opposite. It means to, one of us is coming back. Hold on a second. Since it's in my piece. Activity problem. Okay, good. So metabolizing blood glucose, metabolizing blood glucose. I'm sorry, it doesn't say blood. Metabolizing glucose means to lower the blood sugar. It means to take the sugar, to take the glucose
okay.
out of the blood,
Okay.
right?
Yes.
Metabolize. To release glucose or to mobilize glucose would be to increase the blood sugar. So to take it out of storage and release it into the blood would be to release or to mobilize. To metabolize glucose would be to pull it out of the blood and to store it, to lower the blood sugar, to lower the blood
Okay,
sugar.
so the insulin.
So it should be insulin. That's
Insulin.
right. That's right. Insulin. Now, if you guys, I highlighted this in yellow just because I wanted you guys to be able to find some of these slides easily if you want to go in and practice them. Oh, no. I'm sorry. These are all yellow mistakenly. If you want to come back to this slide and practice it later, there is a description at the bottom, which I think is not correct. And I just want you guys to know about that. And that is that it says the endocrine system is in charge of all the, I'm sorry, it says, where's my glucose question? Whose fault is this? I gotta find somebody to blame for this. I bet it's one of them kids. I'll figure it out somehow. Okay, so it says down here, it says insulin is a hormone produced by the pancreas and reduces or metabolizes blood glucose levels. That's correct. It's the next sentence. Just ignore. Glycogen is a polysaccharide of glucose. It's just not relevant for our purposes, and also doesn't describe the function of doesn't describe the relationship between glycogen and insulin or the pancreas, glycogen and the pancreas. So it kind of is incomplete in my opinion. Anyway, it doesn't matter. Just ignore that second sentence if you choose to review, which I hope you will. Okay, so now we're going to look at the therapeutic effects of massage applications. So massage applications are hand techniques and other things like cupping or hot stones or the application of heat or cold cryotherapy. It can also be scraping, which is called gua sha. And massage applications have two sections. They have the mechanical section. The mechanical section is what you do to the body. It's what the technique or the application does to the body. So when you do petrissage, for example, when you go with the fibers of the muscle, you're lengthening or stretching or relaxing the muscles, right? When you take your hand, that's the mechanical effect. And then there's the reflexive effect. So reflexive is the body's response to the technique. So when you do petrissage, you're having the mechanical effect of lengthening and releasing the muscles. And you hope that the reflexive effect will be that the muscles will retain some of that length and will be more relaxed afterwards. So a lower tonicity or a little bit more range of motion or flexibility in the muscles would be a reflexive result of petrissage, and lengthening the muscles or stretching the muscles would be the mechanical effect of petrissage. I have a chart where I collected for some, unfortunately not all, for some hand techniques, I collected both the mechanical and the reflexive effects. If you just read like the first sentence of each one of these, it'll have most of what you need, right? So for example, effleurage helps to move blood and lymph, and then has longer lasting capillary dilation and deep muscle relaxation. And there's some other more specific information for some of these, and that's cool, but you're not gonna need everything in this chart for sure. Just do like the first sentence to start with to build your familiarity, and then you can add a second layer, a third layer below that. most of the hand techniques, they're going to cause ischemia mechanically. So the mechanical effect will be ischemia. Isk means to occlude or to stop, right? And emia refers to blood, right? So ischemia means to stop the blood flow. And then hyperemia means an excessive amount or a larger amount. And emia means blood. So hyperemia means a larger amount of blood flow. That's the reflexive effect. So the way that the body responds, let me back up. So many massage techniques, because they involve putting pressure into the muscle tissue, into the skin, and there are blood vessels all throughout the skin and the muscles. Many massage techniques, their mechanical effect is going to be ischemia. And the reflexive technique, what the body does after you take the pressure off, for most of the hand techniques, is it increases the blood flow. That's hyperemia. There are some which will actually increase the circulation right away. I think those include Swedish gymnastics and, for example, tapotment. I think maybe one tapotment or percussion. Oh no, tapotment first does temporary ischemia, like many of the others. This chart is good for you just to have something to organize the information, but it should not be the first thing that you look at. It should be like a reference. I think the first thing should actually be these therapeutic massage application questions. And I can get more of them. I'll be getting more of them for you. I think this is all that I have for now, but this is actually plenty. And these are from a site called YouGoPrep, which is pretty good. They have some questions which are a little bit too in-depth, but not many. And we're not going to see any of those here on the massage applications questions. But I'll get some massage application questions from the AMTA and the FSMTB. I actually just finished the FSMTB 100 question quiz that comes with the membership. And there weren't very many massage application questions on there. But even if there's one or two, I'll pull them out and put them in this slide for you. So without further ado, so what I want you guys to do is I want you guys to make a note of which questions, like write down which questions were confusing to you, so that you can come back and practice them. You may recall that I said that some things we can learn just by drilling questions, just by doing practice questions, and this is one of those things. What is the name of the non-invasive therapy designed by John E. Upledger? Is that craniosacral, lomi-lomi, manual lymph drainage, or active isolated stretching? The answer is craniosacral. Increasing waste removal is a mechanical effect of what type of treatment? You guys go ahead and unmute and call out the answer if you want to. Increasing waste removal is a mechanical effect of what type of treatment? Fine vibration, light effleurage, jostling or shaking, or Swedish gymnastics? Waste removal. And the answer is Swedish gymnastics. Swedish gymnastics. Relaxing the muscles and decreasing hypertonicity is a reflexive effect of what type of treatment technique? Relaxing the muscles and decreasing hypertonicity is a reflexive effect of what type of treatment technique? Tapotment, direct pressure friction, coarse vibration, or light effleurage?
Is it B?
That would be direct pressure friction. That's correct. And who answered B?
Khalees.
So Khalees, what is a reflexive effect? Is that the body's response to the manual technique, or is it what the technique does to the body?
The body response.
Yes. And does that come first or second?
Second.
That's correct. Of the following physiological effects, which is a reflexive effect for deep effleurage? Increases vasodilation, stretches veins and lymph vessels, increases waste removal, or moves nutrients through the vessels? Which ones do you guys think it might be?
B.
Okay, does stretching veins and lymph vessels, does that sound like a mechanical thing, like that the hand technique does to the body? Or does that sound like a reflex that the body does in response to the technique?
Right.
Does that sound like what the hand does to the body,
the
or what
hand
the body
does.
responds to? Yeah. Dominique,
But
What the body
hand
responds
does.
to.
it's what the hand does to the body, stretching veins and stretching lymph vessels. It's what the hand does to the body.
Mhm.
So that would be which one, mechanical or reflexive?
Mechanical.
Yes. So the answer is that it increases vasodilation. That's the reflexive effect for deep effleurage. The mechanical effect is stretching veins and lymph vessels. It also increases waste removal and moves nutrients through the vessels. So while you're working with your hand, you're moving nutrients through the vessels, increasing waste removal and stretching the veins and lymph vessels. And the body afterwards increases the vasodilation. Do you guys know what vasodilation means? Does anyone not know? Vaso means vessel, like blood vessel. Dilation means opening. Opening the blood vessels, opening the blood flow. Yeah. Most reflexive techniques will be vasodilation or hyperemia. Hyperemia and vasodilation, they're basically the same. Which of the following physiological effects is a mechanical component of cross-fiber friction? Which of the following physiological effects is a mechanical component of cross-fiber friction?
B.
Breaks up and reforms scar tissue. Yes, that's correct. Breaks up and reforms scar tissues. Yeah. Notice they have hyperemia listed. Hopefully that makes sense to you as something that would happen after you remove the pressure of cross-fiber friction. That would be a reflexive response. Hyperemia, this one's in yellow because a lot of people miss it. Hyperemia is a reflexive effect of what type of treatment technique? Direct pressure friction, deep effleurage, petrissage, or coarse vibration?
B.
The answer is direct pressure friction. So this one I found to be really tricky because if my memory serves correctly, I cannot find a reference for hyperemia as a reflexive technique for deep effleurage. I found it for the other two, but not for deep effleurage. But this is one of those questions that I want you just to study as a question, so that you remember hyperemia is a reflexive technique for deep pressure friction, but not for effleurage, deep effleurage, not for petrissage, not for coarse vibration. And that, that doesn't make a lot of sense to me, but I want you to memorize it like that. Let's actually look at the chart for petrissage, because where is petrissage? Okay. So we're looking at the reflexive effects. So it does not list, I did not find hyperemia as a specific reflexive effect. Maybe they just don't think about it that way. They do say that petrissage increases blood pressure if done on the abdomen. So maybe they want to save that to be really specific, and maybe this question is more general, more systemic than local. I don't know. Direct pressure friction. Temporary ischemia is a mechanical effect of what type of treatment technique? Light effleurage, tapotement, jostling or shaking, fine vibration. Temporary ischemia. So with light effleurage, with light effleurage, are you going to be occluding, like pressing down or stopping? Are you going to be Stopping the
Deponent.
blood flow? Or are you going to be moving the blood?
I'm moving.
Yeah, and with tapotement,
Deponent.
gonna be-
Stop it. Stop it
stopping,
going.
yeah. And how about with jostling or shaking? Do you think you would move the blood or stop it that way?
No.
You think you would move the blood with
Yeah.
jostling, shaking, and fine vibration?
Yeah.
So it's tapotement. Yeah. This is a good one to go back to and review. Who is given credit for the invention of Swedish massage? Galen of Rome, Per Henrik Ling, Yellow Emperor, or Buddha? This is just silly. Where's Swedish massage from?
Yeah.
From Sweden.
Sweden.
Is Rome in Sweden? Rome is in Italy,
No.
right?
Right.
Or Henrik Ling, that looks, yeah, the Yellow Emperor. This is a ridiculous question. These are both from different parts of Asia. Yellow Emperor is from China, Buddha is from India.
Yeah. So
B.
So Per Henrik Ling, Per Henrik Ling. Yeah. What is the name of the two brothers who introduced Swedish massage to the United States in 1856? Is it the Taylor brothers? Jacoby and Victoria White? Is it Ambrose
It's
Pear? Or Metzger and Kellogg? It's not D. It's not D. It's A, the Taylor brothers. Taylor brothers. What is the proper stance for giving a massage? Feet parallel to the table with the weight on the back foot. Body properly aligned with knees bent, shifting the weight with the flow of strokes. Feet parallel to the table with the weight on the front foot, or knees and elbows locked with arms outstretched. I would go with the one that sounds the best in this question.
For giving a massage.
B.
Body properly aligned with knees bent.
By the way, the flow strokes.
Yes. Hacking, cupping, and tapping are all types of what? Percussion, compression, petrissage, or effleurage?
Percussion.
Compression.
Percussion, yeah. Do you guys like percussion techniques?
Yeah.
Do you find them useful?
I don't really use them.
They're very useful. They're the only ones that break up phlegm. This is an MBLEx question. They're the only ones that it's the only technique that breaks up phlegm. And also, oops. I'm like erasing my stuff here by mistake. Percussion. Tapotement or percussion is the only one that loosens mucus in the thoracic cavity. And it's one of the it's one of the few that can actually stimulate. It's one of the few that can actually stimulate the nervous system and can activate the muscles. So it can stimulate the muscles. It can stimulate the nervous system. So it can be used. It can be good for like sports massage, around an event, like before an event. If you want to activate the muscles and activate the nervous system, petrissage is a good technique to do. That's also an MBLEx question, which I think we're going to see. And then if you do it for a period of longer than 3 minutes, it actually increases the muscle tone. And what else does it do? Oh, it stimulates the organs. It stimulates the lungs. It stimulates the abdominal organs. So it's very stimulatory, right? It stimulates and activates. And it moves mucus. It's the only one that does that. Stimulating synovial activity is a mechanical effect of what type of treatment technique applied over the sacrum? Stimulating synovial activity is a mechanical effect of what type of treatment technique applied over the sacrum? So synovial activity, some of you might not remember what synovial is. So synovial activity is the production of lubricating fluid in the joints produced by synovial cells. And if you're stimulating synovial activity somewhere in the area of the sacrum, if you want to get the joints around between the sacrum and the ischium looser, what technique would you use to stimulate the production of synovial activity? coarse vibration, light effleurage, fine vibration, or jostling and shaking over the sacrum? What would you use? The answer is coarse vibration. Yeah, coarse vibration. Oh, I'm sorry that I told you that percussion or tapotement was the only technique that loosens mucus. It looks like coarse vibration also loosens mucus in the synovial cavity. It loosens mucus in the thoracic cavity and stimulates synovial activity over the sacrum. Its reflexive effect is penetrating stimulation. So it penetrates deeply into the body, I guess. When an entire body system is being stimulated, it is called Price, hydrotherapy, connective tissue approach, or systemic massage. Which one?
Systemic massage.
Yeah, D.
Systemic massage. That's right. D. Systemic massage. Avoid passively stretching in acutely spasmodic. I don't know why I'm reading like this. I'm sorry. Avoid passively stretching an acutely spasmodic muscle with inflammation, chronic pain, scar tissue, or granulation tissue. So a client comes in and says, I have I went running yesterday and I got a calf cramp. And you're thinking, okay, I'm going to stretch that calf out, but then they lay down and you look at the muscle and you notice there is inflammation, or you look in the chart and you notice they have chronic pain in that area, or you palpate and it feels like things are stuck together and there's a scar there, or there's like there's an old wound there, or granulation tissue, which is an aspect of scar tissue. Which one do you think it is? Acutely spasmodic. What happens in acute injury?
Inflammation.
Inflammation, that's right, inflammation. In many acute injuries, there's inflammation, and one thing that happens is spasm, right? So this is describing acutely spasmodic, and you guys can remember SHARP, which is spasm, heat, altered movement, redness, and then pain. So that's inflammation. Often is accompanied by these. SHARP. Yeah, so spasm is part of inflammation, right? And the fact that it's acute should help you eliminate the phrase chronic pain. Acutely spasmodic should eliminate chronic pain. Acutely spasmodic should also eliminate scar tissue and granulation tissue, because those are for old injuries. Which of the following physiological effects is a reflexive component of petrissage? Reflexive component of petrissage increases blood pressure on the abdomen, stretches veins and lymph vessels, increases venous flow, or increases waste removal. The answer is that it increases blood pressure on the abdomen. So this is in yellow. So you guys go to the MBLEx drive, go down to therapeutic massage applications, open it up, and then go for the yellow ones to practice as part of your basics. Okay. Oh, let me just go through these just so you've heard them and to remind you. So for petrissage, the mechanical effects are stretching the veins and lymph vessels, increasing the venous flow, increasing waste removal, decreasing adhesions, moving interstitial fluids, stretching and broadening the muscle fibers. And then the reflexive effects are relaxing the nervous system with slow strokes, stimulating the nervous system if you use fast strokes, increasing peristalsis on the abdomen, also increasing blood pressure when done on the abdomen, positive effect on proprioception, and decreasing hypertonicity, increasing glandular activity of the skin. Temporary ischemia is a mechanical effect of what treatment technique? Temporary ischemia is a mechanical effect of what treatment technique? Is that linear or circular friction, light effleurage, fine vibration, or jostling and shaking? Linear or circular friction, light effleurage, fine vibration, or jostling and shaking? Mechanical effect, temporary ischemia. Well, ischemia means, go ahead.
Oh, I was gonna say linear or circular friction, but go ahead.
Well, ischemia means what? Occlusion or increasing blood flow?
Stop blood flow.
Yeah, to stop blood flow or to increase blood flow. I'm happy to repeat any of these word breakdowns, any basic piece of information. If you want me to repeat it, you just unmute and call out. Can you repeat that, please? Right, because we really cannot hear this like too much. This is what practice means. So if you're doing friction, if you're doing like linear friction or circular friction, are you pressing in a way that causes ischemia, or are you actually moving blood flow?
Moving.
Moving. If you're doing
Yeah.
light effleurage, are you causing ischemia, or are you actually moving the blood?
Moving the blood still.
Moving.
How about fine vibration? Ischemia
Yes.
first?
Yeah.
Yes. How about jostling and shaking? Does that cause
No.
ischemia? Okay.
No.
Okay. Oh, linear or circular? I'm sorry, I totally misled you. Not intentionally either. Linear or circular friction, mechanical techniques, broadens and stretches muscle tissue, temporary ischemia.
Yeah. Because you're rubbing.
Decreases. I would think the rubbing would actually push the blood, but the pressure from the hand must be significant enough that it stops the blood flow. And that makes sense because it also decreases fascial adhesion. So you're actually getting a moderate to heavy pressure in there, and increases muscle extensibility. Extensibility is the ability to stretch or change shape. Okay. All right. I'll get some of these wrong until I look at the answer. Linear or circular friction. Let's see what reflexive effects linear and circular has. Hyperemia, which happens after ischemia. Relaxes and decreases hypertonicity, especially if done on a tendon or a Golgi tendon organ. Golgi tendon organs are in the tendons, and increases circulation. What is the job of the Golgi tendon organ? Is it to sense stretch and the speed of stretch, or is it to sense the load?
The load.
The load, that's correct. And what's the name of the organ, or what's the name of the fibers or the cells which sense stretch or speed of stretch?
Mm,
The sensory.
Sensory is its function, and you can say that they are afferent sensory
Afferent sensory.
muscle what fibers? They're inside what?
That's
The spindle.
okay. Yes.
The spindle. And when it's inside the spindle, it's also called what? Intrafusal or extrafusal?
intrafusal.
Interferes.
Intrafusal. And which one does most of the prime moving, most of the heavy work of the muscle? Is that intrafusal or extrafusal?
Interfusal.
Extrafusal. Yes, very good. Very good. Okay, before treatment and recommendation of a self-care program, consult with the client on all aspects of the condition and the desired outcome. With early stages of a joint injury, which of the following remedial exercises are appropriate? With early stages of joint injury, which of the following remedial exercises are appropriate? Active assisted exercises, active resisted isometric, passive joint mobilization, or active resisted isotonic?
Active assisted.
It's not a bad place to start, but it is incorrect.
Mm,
So isometric means applying force but not lengthening or shortening the muscle. Wait a minute, isometric or isotonic? I may be confusing these. Okay, everybody, don't look. Yeah. And then isotonic, what did you didn't look, did you? And then isotonic means where you apply force, but you actually change the length of the muscle, you shorten it, or in the eccentric, you would lengthen it. So if someone is having an early, if it's the early stage of a joint injury, can you see that it would be safer not to shorten and lengthen the muscles connected to the joint?
Yes.
Safer not to shorten, lengthen them. Yeah. So if you wanted to wake up the muscles and activate them and get the muscles to squeeze the blood vessels to increase the blood flow a little bit, can you see how isometric exercises would be safer?
Yes.
Okay.
Yeah. Anything where you're actually moving the joint, isometric doesn't move the joint. It doesn't shorten or lengthen the muscles. Anything that's moving the joint, like active assisted stretching, passive joint mobilizations, where you take someone's joint and you move it through its natural range of motion to try to open it up, or active resisted isotonic, any kind of isotonic exercise where the joint is moving and the muscle is changing shape, might be really irritating, especially if there's any kind of tear, tendon tear, ligament tear, muscle tear. To obtain actually I should put that one. My background option, I see. I have to get rid of that. This is fine. To obtain a balanced standing position during a massage, you must what? Tilt your head back and neck to the side, align your head and neck with your spine, pelvis, legs, and feet. Medially rotate the head to the opposite side of your lead foot. Laterally rotate the head and neck to the same side as your lead foot. This is a silly question.
Yeah,
Just go with the one that sounds good. Yeah, align.
Line.
Yeah, align. Yeah. In 129, I hate that they ask you these questions, but I have seen flashcards on, I have seen like more than one source with this question. So we'd better be prepared. In 129 through 199 AD, Rome 16 books on frictions and gymnastics that describe the pressure, direction, and frequency of treatment were written by Buddha, Yellow Emperor, Ambroise Parr, or Galen of Rome.
Ambrose Parr.
In 129 to 199 AD Rome.
Oh, Galen of Rome.
Galen of Rome, yes. Which treatment would be most effective for a client that presents with a subacute ankle sprain? What does subacute mean?
Kind of like halfway there.
Yeah, kind of like halfway there. Yes, excellent. So acute means early. Subacute means kind of between acute and healed, or between acute and chronic. We hope it doesn't become chronic, but a lot of times it does. And chronic means longer than 3 months, longer than 6 months, depending on who you ask. It depends on who you ask. So which treatment would be most effective for a client that presents with a subacute ankle sprain? Petrissage, friction, effleurage, or vibration?
Vibration?
Yeah, most effective. I mean, vibration is pretty gentle. With a subacute ankle sprain, most of the inflammation will be gone, and you'll have scar tissue starting to form. You'll have some stiffness.
Friction.
So friction, yeah, friction. Which of the following effects is a reflexive component of petrissage? Is it that it increases waste removal, increases venous flow, stretches veins and lymph vessels, or that fast strokes stimulate the nervous system? So guys, I want you to get to the point where you remember that petrissage does all of these first three. However, if you, wait a minute, am I sharing my screen?
Yes.
Okay, good. I want you to get to the point where you remember that petrissage does all the first three mechanically, and fast strokes stimulate the nervous system reflexively. But if you can't remember that, try to use process of elimination or to find what the answers have in common. So stretches veins and lymph vessels, that would increase venous flow, right? So these two have that in common, the increase in venous flow. And that also would result in the increase in waste removal. So waste removal and venous flow happen secondarily or after stretching the veins and lymph vessels. And maybe you'll remember that petrissage stretches veins and lymph vessels as its mechanical effect. And the reflexive effect is fast strokes stimulate the nervous system. Slow strokes, let's see. Slow strokes relax the nervous system. Fast strokes stimulate the nervous system. Increases peristalsis on the abdomen. Increases blood pressure on the abdomen. So in yellow, yeah. Stimulating organs is a reflexive effect of what type of treatment? Coarse vibration, tapotement, Swedish gymnastics, or light effleurage? Stimulating organs, reflexive. It's not very clear. It's not a bad guess, not a bad guess. It's not very clear, but it is tapotement. Tapotement. So tapotement loosens mucus. Oh, I'm sorry. The reflexive effects of tapotement. Where is that? Here we go. Hyperemia. Stimulation of the nervous system, stimulation of the muscles, stimulation of the blood vessels and skin, right? Numbing effect if done for more than 3 minutes, increases muscle tone. And it also stimulates the organs, specifically the lungs and all the organs in the abdomen, because you do it over the low back, I guess. Okay. So you should come do this one. Come do these like every day, you know. How are you feeling with your planes and your we're out of time, unfortunately, but we got through almost all of them. There's one more. Well, we'll do one more. Okay. Decreasing sinus congestion is a reflexive effect of what type of technique? Decreasing sinus congestion, is that petrissage, direct pressure friction, light effleurage, or cross fiber friction? The answer is direct pressure friction. Compresses and spreads tissues and causes temporary ischemia. The reflexive effects are hyperemia, relaxes muscles, decreases hypertonicity. Okay. How are you guys feeling about your basics, like the planes, joint ranges of motion, understanding concentric versus eccentric? Emmy, Khalees, can I hear from you guys? Emmy, Khalees, Stephanie, can I hear from you guys too?
I feel confident about it.
Okay.
I'm
Does
feeling
anybody,
better.
does anyone feel like they need to review for
No.
next time?
No,
Okay.
we're good.
Okay, great. So then we'll start to drill some of these next time. And we'll also drill some of the hormones. We'll start to replace the basics with some of the stuff we've done more recently. Okay, if there's anything that's really unclear or giving you trouble or that you want to practice on a regular basis next time, starting next time, just let me know. And I'm going to